Welcome guys to the session. So today we'll be starting with the previously requested calculus question. Is everyone able to see the screen? How about that? Okay. So you guys previously asked for question 9.3 to show for which values of x is the graph increasing, right? Yes. So if you guys remember from my explanation before about the value about how the graph looks when a is positive and a is negative. So as you can see in this question, right, your value of a is going to be positive because when f is derived, you've got a positive a value. So you know the previous a value for the original cubic function will also have a positive a value. So from there you know that your a is greater than 0. So your graph is going to look like this. Okay. So the question wants to know for which values of x is the graph strictly increasing. So to get our turning points, right? So we need to have our turning points first because the graph is going to increase at these points, right? Okay, so do you see from here to here the graph is increasing, and then the graph is decreasing from here to here, and then it's increasing again, because you can see for this part here, as the x values are increasing, the y values are also increasing. So you know it's an increasing function. And then here, as the x values are increasing, your y values are decreasing. So this is a decreasing. This area here is decreasing. And for this part here, as your x values are increasing, your y values are also increasing. So this area shaded in blue and this one as well are both increasing functions, right? The x values over there are increasing. So in order to get these points, you need the turning points, right? And if you remember, the turning points for the cubic function is actually the x values for the turning point of the cubic function is actually the x values of the x-intercepts of the quadratic function. Does everyone understand that part? Yes. So, okay, so we're going to need to get our turning points again. So we're going to have y is equal to 3x squared, 3x squared plus 8x minus 3. So plus 8x minus 3, okay? So then we'll have y is equal to, then we'll have 3 and 1, and let's make it positive 3 over here, and negative 1 over here as our factors. So cross multiply, we'll have negative 1 over here. What's going on? Okay. And then we'll have 3 times positive 3, which is positive 9. And subtract those two, you get positive 8, which is what we want in the middle. So we'll have 3 x minus 1 and x plus 3. Okay, so x values of our our intercept are x is equal to 1 over 3 or x is equal to negative 3. Okay, so now that we have our x values, we know that this point over here is going to have a x value of negative 3. So x is going to be equal to negative 3 over here, and this point over here is going to have an x value of 1 over 3. Okay, 1 over 3. So from there, our answer is just going to be the graph of x. Our question was, just to repeat the question, determine the values of x for which f is strictly increasing. Okay, so in this question now, our graph is strictly increasing for the values greater than 1 over 3 and the values less than negative 3. Does everyone understand the explanation now? Okay, so can we move on to analytical geometry? Okay. Yes, you may. So sorry, I can't hear what you're saying. You don't have to. The sketch is just to help you understand. If it helps you understanding in order to get the answer, you can draw the sketch. The sketch was just to explain, because the last time when I did this question, I didn't draw the sketch. I just explained and gave an answer, and people seemed a bit confused. So I drew the sketch now just to explain how I arrived at my answer. Okay. Okay. If we have a bit extra time today, I'd actually like to go over, yesterday we only did future value for finance. I'd actually also like to do a question on present value if we have a bit of time before 7, okay? And maybe if we can also push a statistics question either today or tomorrow. Okay, so analytical geometry, right? Is everyone able to clearly see the screen? How about now? We only need the first part of the question. Guys, if you're not asking a question, please can you mute your mics? Okay, so question 3.1, right? Okay, in the diagram below, the line joining Q, the line joining Q, which has coordinates -2 and -3, which is this point over here, and P. Guys, if you're not asking a question, please can you mute your mics? Okay, in the diagram below, the line joining point Q, which has coordinates -2 and -3, and point P, which has coordinates A and B, where A and B are greater than 0. So you know that A and B has to be positive values, right? Make an angle of 45 degrees, which is this angle over here, with the positive x-axis. Point QP, which is this line over here from Q all the way to P, has got a total length of 7 and 2 and root 2, right? Units. Point N, which is this point over here, has coordinates 7 and 1 and is the midpoint of PR. So this line over here, PR, has midpoint M, and M is the midpoint of QR. So QR is this line over here, and its midpoint is M, right? So the first question says determine the gradient of PQ. So in order to determine the gradient of PQ, we don't really have the value of P, right? To use that previous formula of M is equal to Y2 minus Y1 over X2 minus X1. We don't have our P coordinates to use that formula. We also don't have the gradient of any other parallel lines or any perpendicular lines in order to use our perpendicular and parallel rules. The only other thing that we have is the 45 degrees, right? And if you guys remember the formula, M, which is gradient, is equal to tan theta. We are able to use this formula because we have the 45 degrees. So we can actually calculate our gradient of PQ, which is equal to tan 45 degrees. And our gradient is therefore MPQ is therefore equal to tan 45 degrees is 1 unit. Yes. I'm sorry, I can't hear what you're saying. You can put the unit if you want, or you don't need to put it. You won't lose a mark or gain a mark. Okay. Okay, so the next question, question 3.2. So question 3.2 wants us to calculate the equation of line MN in the form y is equal to mx plus c and give reasons for our answer, right? So if we are going to calculate the equation of line MN, so line MN is this line over here. I'll highlight it in red. So we need to find the equation of this line, right? So when we look at this triangle, we can clearly see that it's given to us that this angle is equal to this angle, and this angle is equal to this angle, right? So there's two things that we can use to actually calculate the gradient of line MN, because remember, in order to get the equation of a line, we need a coordinate point and we actually need the gradient of that line. Okay, so the first option we can use is the midpoint theorem, and the second option we can use is corresponding angles, because remember, corresponding angles needs to have a F shape, and as you can see here, this has got an F shape, right? And this part is equal to this part. So you can use corresponding angles and say therefore line PQ is equal to the gradient of line PQ, PQ is parallel to NM, which means that they will have the same gradient since they're parallel. Or alternatively, you can use the midpoint theorem, and the midpoint theorem states that line MN will be equal to not equal in distance, but the gradient of line MN will be equal to line PQ because they are parallel. Okay, and also the midpoint theorem states that line PQ is double the size of line MN, or alternatively line MN is half the size of line PQ. Okay, so by using the midpoint theorem, that can be our reason, right? So we just say the gradient of the gradient of PQ is equal to the gradient of MN, which is equal to 1, and we can just write midpoint theorem. Midpoint theorem because line PQ is parallel to line MN. Okay, so now we have the gradient of our line. The next thing that we need is a coordinate point, and we've got point N, right? Because point N is a coordinate, or is a point on line MN, which is the line that we are trying to calculate the equation of a line of. We can't use M because it doesn't have a coordinates. So the only option is to use point N. So we've got y minus y1 is equal to mx minus x1. And this is our equation of a line formula, right? So we're going to substitute using our coordinates of n. So we know the x coordinate of n, which is x1, is equal to 7, and the y coordinate of n is equal to 1. So when we substitute, we just substitute these values. So it's going to be y minus 1 is equal to our gradient. Our gradient is 1, open a bracket, x minus our x1 value is 7, and close that bracket. So now we need to simplify this into the form y is equal to mx plus c. So we're going to have y is equal to, 1 times anything is still that same thing. So you can just write 1 times x is equal to x, and 1 times negative 7 is equal to negative 7. And transpose the negative 1 to the right side, and you get positive 1. And you will therefore be left with equation of line MN is equal to x minus 6. Does everyone understand before we move on to the next question? Okay. So question 3.3. Question 3.3 wants us to calculate the length of line MN. So let me just clear this up. Did everyone take down the question 3.1 and question 3.2 before I clear it up? Sure. Okay. Zoom out of the question or out of the answers? Okay. Here's the answers. Okay. Okay, so question 3.3. Calculate the length of line MN. Sorry, I'm just repositioning this question. Okay, so in order to calculate the length of line MN, right, what we can do is we can use our midpoint theorem. So if you remember previously, I said the length of MN is equal to double the length of PQ, and alternatively you can say the length of PQ is half the length of MN. So to write this, you'd say M, which one am I saying? So you'd say PQ is equal to twice MN, or alternatively you can write MN is equal to half PQ. Is everyone able to see, and am I audible enough for everyone? Yes? Okay. So to continue with the question 3.3, calculating the length of MN. Yeah. It depends on which. Okay, if they asked us to find the length of PQ, I would have used this. I would have just said PQ is equal to twice MN, and then just substituted the value of MN if it was given. But if they asked us to calculate the value of MN, I would have went with this straight away and said MN is equal to half PQ and substituted the value of PQ and got my answer. I just mentioned both so you guys can see like the different ways of saying it. Like if you say X is equal to 2 and 2 is equal to X, is there a difference? Because X is still equal to 2, right? Okay, so back to the question, right? Yeah. Yeah. Yeah, the reason is midpoint theorem. Okay, so calculating the length of MN. So if you remember previously in this top paragraph, they actually gave us the length of PQ, right? Which is 7 root 2. Guys, can you mute your mics if you're not asking a question? So we have MN is equal to half PQ, which is therefore equal to half of 7 root 2. And when you put this on a calculator, you have MN, you've got MN is therefore equal to 4,955 units. And since we're calculating distance, it is preferable to use units. If they give you like it was equal to 7 root 2 centimeters, then we could have had our final answer as 4.95 centimeters. But since they gave us our unit as units, you just leave it as units, okay? So does everyone understand question 3.3 before we move on? Okay, so question 3. Okay. So question 3.4. Question 3.4 wants us to calculate the length of RS. So the length of RS, where is RS? Okay. So RS is the dotted line over here on the right hand side. And you can even see it's worth 1 mark. So there isn't really much calculation or thinking involved, right? All you can do is you can say that the length of PQ is actually equal to the same length of RS. and we know that the length of PQ is 7 root 2, right? So for question 3.4, you've got here, because you can see that, okay, let me clear up this question, then I'll explain. Okay, so do you see this line over here, Pn, which is the Pn is equal to Nr, and by this you'll know that Qn is equal to Ns. So therefore, you can see that this is a parallelogram, right? So properties of a parallelogram, opposite sides are equal, right? So PS would be equal to QR, and SR would be equal to PQ, and the diagonals would be equal, like this line is equal to this line, and this line is equal to this line. Then this is equal to this, and this is equal to this. Do you understand? Okay. I think in the grade 9 Platinum textbook, they've got in term 3, they've got like all the properties of shapes and stuff like that you can just go over. Because analytical geometry and Euclidean geometry, you actually, it's advantageous to know the properties of shapes. Like, for example, you would have lost this 1 mark if you didn't realize that PQ is actually equal to SR. Okay, so PQ is equal to RS, and PQ is equal to 7 root 2 units, right? Yeah. Yeah, you can say that opposite sides are equal, and then in brackets you can put, or you can just put opposite sides of parallelogram are equal if they asked you for a reason. Oh, excuse me? I didn't catch what you said. Well, to be honest, it's a 1 mark question, so all you need to, they didn't really ask you for a reason, and it's just 1 mark. So all you need to show that RS is equal to 7 root 2, and then you get your mark. There's not really any calculations or in-depth thinking or anything like that. Just put down your, because if you look at the diagram, right, you can see that the diagonals are equal. You can see that the opposite sides are equal. So you can already see that PQ is equal to SR. Then you just put your 7 root 2 and you get your 1 mark. That's it. Okay. So question 3.5, right? So question 3.5 says the coordinates of S such that PQRS in this order is a parallelogram. Okay, so here they actually gave us that it is a parallelogram, right? So if you maybe read through the questions, like when you start your question paper, if you're the type of person who reads like from question 3.1 until question 3.6, you read the whole question, maybe then you would have got a hint for question 3.4 from question 3.5, right? Like even with functions, some questions they have that where they say like calculate the value of a, and then in the next question they say if the value of a is equal to whatever, calculate this. So like you get clues to the previous question if you read the next question sometimes. Okay, so for question 3.5, right? Question 3.5 wants us to calculate the coordinates of S such that PQRS in this order is a parallelogram. So in order to calculate the coordinates of S, you can see that we've got Q to N, which is half a diagonal. Then we've got Q until S, right? Let me just draw this line properly. So we've got line S, N, and Q, right? And line SN is equal to line NQ, which means that point N is the midpoint of QS. And I think they gave us that in the top paragraph, right? That N is the midpoint of QS. So now we can actually calculate the coordinate of S using midpoints, right? So you guys know the midpoint formula. M is x1 plus x2 all over 2, and y1 plus y2 all over 2. Okay, so from here we have our value of n, our x value of n, which is equal to our x value of q plus our x value of s all over 2. And to calculate y, we've got our y value of n, which is equal to our y value of q plus our y value of s all over 2. So now all we do is we substitute and then solve for xs, because we want the x coordinate of s and the y coordinate of s. Okay, so we know that our x value of n is 7, which is equal to our x value of q, which is -2, plus, now we don't have our x value of s, that's our unknown, so we just leave it as xs all over 2. Now all we can do is simplify and solve for x. So from here we can cross multiply. So we know this is 7 over 1, and the 2 cross multiplied over there, the 1 you can cross multiply it over there. Okay, so 2 times 7 is 14, and 1 times -2 is -2. 1 times xs is xs. Now we can solve for xs. So we've got xs is equal to 14 plus 2. Okay, and then we know our x value of s is now 16. Does everyone understand how I calculated the x value before we move on to the y value? Okay. Is anyone lost? Okay, sharp. So now to calculate our y value. So now we need to get the y coordinate, or the y value of n. So our y value of n is now 1, and our q value of our y value of q is -3. So we need to substitute 1 and -3. So 1 is now equal to -3 plus the y value of s all over 2. Now we can cross multiply again, and we would have 2 is equal to -3 . So we have 2 is equal to -3 plus y s. Okay, now we can get our final ys value as 2 plus 3, which is then 5. So our s value our y value of s is now 5. So we can write our final coordinate as 16 and 5. Okay, so whoever needs to take a screenshot of the answer before I move on to the next question. Can I move on? Okay. Does anyone have any questions before I move on? Okay. Okay, so our last question, question 3.6. So question 3.6 says determine the coordinates of P, right? So P is that one there on top that's got our X value as A and our our Y value as B. So let's see, how can we do this? Okay, so we've got the equation of line PQ and we've got the length of line PQ, right? So let's start off like this and see how it goes. Okay. So does anyone? Okay, that's the bottom here. Question 3.6 just wants us to calculate the coordinates of P. They want us to calculate the values of A and B. Okay, so question 3.6, right? So our equation of line PQ was equal to, was it x minus 6? If someone can just confirm that. I raised it, so I can't really, it was okay. So our equation of PQ was x minus 6, right? Now using our P point, we can substitute. So our Y value would be B and our A value would be X. So we can substitute that into it. Okay. Are you guys sure that the length of are you guys sure that the equation of PQ was x minus 6? Oh, okay. Did we calculate the equation of PQ? We didn't. Okay, let's try and calculate it then. Okay, so if we calculate the equation of PQ, right, we remember that our gradient was 1, right? So we'd have y minus, and then we need a point, right? Our coordinate point, which we can use as Q. So we can have y minus -3, which would then become y plus 3 is equal to our gradient, which is 1 times now x minus -2, which would then just become x plus 2 because negative times negative is positive, right? So here we'd have y is equal to x plus 2 minus 3, and y would then be equal to x minus 1. Okay, so this is our equation of PQ. X minus 1. Okay, so from here we can substitute our values of P, which is B is equal to A minus 1. Okay, that can be our first equation. Now we need to get our second equation, right? So our second equation, we're going to use the distance formula since we have the distance of QP. So our distance of QP is then QP is equal to the root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so we can substitute. We know that our QP was given to us in the top paragraph to be 7 root 2. So we've got 7 root 2 is then equal to, okay, so now our x1, so let's make our p values our x and y1 and our q values our x and y2. So we've got a minus negative 2, which will then be a plus 2 squared. Does everyone understand how I'm moving from a minus negative 2 to a plus 2?
Yes, sir.
What do you mean, wait? Are you confused? Okay, let me just explain it quickly for those. Okay, so the formula is x1 minus x2, right? And I'm substituting, so I've got a minus negative 2, right? So you know that negative times negative 2 is just a plus 2. That's how I have a plus 2 instead of having a minus negative 2. It's just to try and skip that step. So does everyone understand that part before we continue? Okay, so the next part, right? So our y1 value is now b. So we're going to have b minus, and our y2 value is negative 3. So we're going to have b minus negative 3, which is then just b, because negative times negative 3 is positive 3. So we have b plus 3 squared. Okay, so from there, now all we need to do is simplify and create an expression on our equation 2. So what we can do to get rid of the square root sign on the left is we can square. So if we square, on the right. So if we square the right, we obviously need to square the left, because you can't just square one side. So 7 root 2 squared would then become 7 root 2 squared is 98. And 98 is equal to, now remember, square root and squared are opposite applications, so they cancel each other out, right? So you'll then be left with a plus 2 squared plus b plus 3 squared. Now we just need to simplify. So we've got 98 is then equal to, so we've got a plus 3 and b plus 3. Okay, wait, this needs to be a, sorry, because a plus 2 squared is, yeah, a plus 2 squared is a plus 2 and a plus 2. So when we multiply, we'll say a times a, which is a squared, and a times positive 2, which is positive 2a. And then we go to the next term, which is 2 times a, which is then 2a, and 2 times 2, which is then positive 4. And we can add up the two middle terms since they're like terms, and we'd have a squared plus 4a plus 4. So this will then become a squared plus 4a plus 4 plus, now the second part, right? Okay, so if you guys remember our equation 1, we had a value of b, which was a minus 1. We can now actually substitute that value of b into this equation now. So we can have plus, so we can have plus, now b is equal to a minus 1. So we just put a minus 1 plus 3 squared. Okay, we then have 98 is equal to a squared plus 4a plus 4 plus a plus 2, right? And from our previous calculation, we know that a plus 2 squared is equal to a squared plus 4a plus 4 plus a squared plus 4a plus 4, which is equal to 98. Now we can take all our terms to one side and add them up. So we can have 0 is equal to, now like terms, right? So we've got a squared and a squared, which would then give us 2a squared. We've got 4a and 4a, which would then give us plus 8a, and we've got 4 plus 4, which would then give us plus 8. And remember our 98 from the left, when we transpose it to the right, we'd have minus 98. Then we then have 2a squared plus 8a minus 90 is equal to 0. Now we can actually write this in standard form. So you guys can see that the only common factor here would be 2. So you can divide this out by 2, divide this out by 2, and you'd be left with a squared plus 4a minus 45. Okay. Which is then equal to 0. So from here we need to get our value of a. So we can have a is equal to negative b plus minus the root of b squared minus 4ac all over 2a, which is then equal to negative, open a bracket, 4 plus minus the root of 4 squared minus, open a bracket, we would then have 4, our value of a, which is 1, our value of c, which is negative 45, all over 2a, and our value of a, which is 1. We therefore have a, which is equal to, so when you put this on a calculator, so our value of a is then 5, or a is equal to negative 9. Okay, so that's our value of A. And remember in the first question, so just back. So the question specified that A and B are both greater than 0, which means that A and B have to be positive values, right? So the -9 is not going to be our final A value. So our final A value is then going to be A is equal to 5. Now we need to calculate our B value. So from our first equation, we had B is equal to B is equal to A minus 1. Yep. Excuse me? I can't hear what you're saying. Why is the video now?
Okay, so no.
Are you confused why I used the quadratic formula? What are you confused with? Wait, I don't understand what you're saying. The value of x is doubles. What do you mean by that? Step number 4. Okay, what step? Step number 4. Okay, which was step number 4? Okay, can you just say like a line, like 98 is equal to a plus 2 squared plus something like that? Plus a, oh, okay, you confused about the part that I substituted here. Let me circle it in green. Are you confused about this part over here? Okay. So the reason that I substituted a minus 1, right? Because remember in our, do you remember this equation up here of b is equal to a minus 1? And now remember this bracket over here, let me write it here, b plus 3 whole squared, right? So remember I had my b equation as a minus 1. B is equal to a minus 1. So all I did was to solve for a, right? Because I had two unknowns. I had unknown as a and I had another unknown as b. So in order to solve simultaneous equations, I used the first equation I had and substituted it into the second equation in order to only have one unknown, which was a. So when I substitute b into this bracket, it's going to be a minus 1 plus 3, and simplified you have a plus 2 squared. Do you understand, or I can explain it a different way if you don't? So you understand? Okay. Is there anyone else that has any other questions regarding anything similar to this or anything about this question before we calculate B? Okay, so I'm going to move on now. Okay, so we have our A value, right? So now what we need to do is we need to calculate a B value. So our B value, we calculate our B value from our previous equation A minus 1, which is then equal to our value of A is then 5 minus 1, and our B value is thus 4, okay, equals to 4. So we've got our coordinate of P. Our coordinate of P is then 5 and 4. So does everyone understand this final question before we move on to something else? Okay, so you guys can take your screenshot and then let me know when you're done so we can move on. Yes. Okay. Yeah. Mm, There's actually a lot of ways to do it. So since we calculated, remember in our previous question, we also calculated the value of S, right? We could have got the equation of line S and got the equation of line PQ, equated the two equations, and then solved for P simultaneously as well. We could have even, since we got the value of R, we could have also used R, the equation of PR and QP, and then solved simultaneous equations. Like, there's a lot of ways that you could have done it. Yeah. Wait, how PQ was? Yeah. I did do the calculations. I just erased it and then wrote the answer further up so we have enough space. Did the rest of you guys see me calculating that as well? Or did everyone not see that? Okay, because remember, we had our gradient of PQ as 1, right? And then I just chose my coordinate Q and substituted that into the equation of a line. And that's how I got my y is equal to x minus 1. So, okay. Does anyone else have any questions? Has everyone managed to screenshot the answer before we move on? Okay. Okay. Do you guys want to do one more financial math question or one more statistics question before we move on with analytical? Okay, so let's go to finance then. See if I still have a question on finance. Yesterday we did future value, right? Yeah. Yeah. Yes. Yes, you can talk. Yes. Do you have a question? I don't think I have a present value question. Okay, let's just do this question. Do you guys just want to do one statistics question and then I'll find a present value question and we can do it tomorrow before our trigonometry session? Okay. I think it was a 2015 paper. Yeah, I think it was November, Gauteng, 2015. Okay, let's just do a quick statistics question and then I'll get a present value question to explain before tomorrow's session. For tomorrow's session. Statistics. I think we did this question yesterday, right?
Yes, sir.
Okay. It's gonna be a waste of time because we already did it. Was there something you didn't understand there? What didn't you understand? You got 0 for R. Oh, were you the guy that had like 8.8 or something as your correlation coefficient?
Yes, sir.
Okay. Okay. You said you had 0, right? So in order to get your R value, you just had to press equals. Because whenever you go into like your standard deviation, your R value, your A or B value, it's always going to give you 0. You have to actually press equals on your calculator to get a value. Oh no, you got 0.8. Oh, okay. I think I explained to you yesterday there was something that you did wrong with when you're inputting your values. Because remember, if you input the wrong values, you're going to get the wrong answer. Still gave you the same thing. Okay, would you mind just sending me a WhatsApp message and then I will explain it to you on WhatsApp a bit later, okay? Okay, just send me a WhatsApp with whatever questions you have and then I will answer all of them on WhatsApp, okay? Do you have my number? I think I put it in the chat. Let me just double check if I did. Okay, let me just put it in the chat again. Okay, yeah, let me just write it up here fast now. It's 07490361445 now. Did you manage to take it down?
Yeah. Yeah, thanks.
Sure. Yeah. Yeah, we're gonna do another analytical. I just wanted to do one more statistics because we didn't really do much yesterday. We only managed to cover one finance and one statistics question. We're still gonna do more analytical geometry. I actually want to do the circle geometry next. Do you guys want to do the geometry first or statistics first?
Geometry.
Okay. Okay, then let's just do the geometry part first. Can do statistics towards the end if we have some time. Okay, is everyone able to see the question?
Yes, sir.
Okay. And now? That's as far as I can go, or is it gonna cut out the question? Is everyone able to see? Is everyone able to see? Okay, so that's, yep. I can't hear what you're saying. Hmm. Okay, I'm gonna move on now. Okay, so the question says, in the diagram below, Q, which is 5 and 2, has coordinates 5 and 2, is the center of the circle, right? Guys, can you mute your mics, please, if you're not asking a question? Okay, yeah. I think this is the same 2015 Gauteng November exam. Okay. So in the diagram below, Q has coordinates 5 and 2 and is the center of a circle that intersects the y-axis at P, which is 0 and 6 and S. So we've got this circle with center Q, and it's intersecting the y-axis at point P and at point S at the bottom. So you can see point S is going to have an x value of 0 and a y value of negative, which will be a negative number. Now they say the tangent APB. So APB is the tangent of the circle at point P, which is 0 and 6, that intersects the x-axis at point B and makes an angle alpha with the positive x-axis. R is a point on the circle and PRS is equal to theta. So PRS, so this angle here by R, that's theta. This angle here by B, that's alpha. Okay, so the first question, determine the equation of the circle in the form x minus a squared plus y minus b squared is equal to r squared. So in order to substitute into this formula, remember our value of a is actually our x value of our center point, and our value of b is actually our y value of our center point. So our center point, which is Q, will have 5, which is our a value, and 2, which is our b value, right? So let's get started with the question. So question 4.1, we've got x minus a squared plus y minus b squared is equal to r squared, right? And we've got our a value as 5, which is x minus, and you substitute 5 squared plus our y value, our b value, which is 2 squared, is equal to. Now we need to get our r value, right? So our r value is actually the radius. Guys, if you're not asking a question, please mute your mics now. So our r value is the radius, which is from the center of the circle, point Q, until the boundary of a circle, which is the only point that we know that has a coordinate so far is P, right? So we need to calculate the distance from Q all the way until P. So in order to do that, all we can do is our distance formula and say we can choose this to be our 1 and our 2 values. So we're going to have x1, which is 5, minus x2, which is 0, squared, plus our y1 value, which is 2, minus our y2 value, which is 6, and that's squared, which is then equal to 5 minus 0, which is 5, squared, which is 25, plus this is going to be negative 4, and negative 4 squared is 16, and this will then become, what is that? That's going to be 35, 41. So we're going to have the root of 41 as our r squared value, right? Sorry, as our r value. So we substitute our value of r into the formula, which is then going to be the root of 41 squared. Okay. So from here we've got x minus 5 squared plus y minus 2 squared is equal to, now to get this, all we do is we know that our root and our squared are opposite operations, and we're left with 41, and that's our final answer since they wanted it in this specific form. So does everyone understand does everyone understand how to answer this question?
Yes.
Okay, so we can move on, right? Do you guys, okay, you guys can take your screenshots before I erase. Just let me know when you guys are. Okay. Okay, so the second question, 4.2, calculate the coordinate of S, right? Guys, please can you mute my whatever that is. So question 4.2, calculate the coordinates of S. So our S coordinate is this intercept over here. So since we know our x value is 0 at point S, we can actually just calculate our y value. So as you can see, point S is still a point on the circle, and we previously calculated our equation of a circle to be x minus 5 squared plus y minus 2 squared is equal to 41. Now to calculate the coordinates of S, we substitute x as 0 into this formula and we solve for y. So we're going to have 0 minus 5 squared plus y minus 2 squared is equal to 41. From here we've got 0 minus 5 all squared, which is 25, and then plus y minus 2 squared is equal to 41. So when we transpose 25 to the other side, we'll have 41 minus 25, which is then 16. Wait, let me just double check that. 41 minus 25, yeah, it is 16. So we'll have y minus 2 squared is equal to 16. So to get the squared side, we can just square root that side and square root that side, and we will have y minus 2 is equal to 16. From here, we can just take it to the other side. So we're going to transpose our 2 value. Oh, and remember this is going to be plus or minus, sorry, that's going to be 4, not 16. Yeah, sorry about that, it's 4. So this is going to be plus minus 4, right? Then we've got 2 plus minus 4, and we've got our y value as 2 plus 4, which is equal to 6, or 2 minus 4, which is equal to 2. So we've got a positive value and we've got a negative value, right? So since we can see that our s value, since we can see that our y-axis is here, so all these values below this are going to be negative, and our s value is within the negative area, we are going to choose our negative value for y. So we're going to have our s coordinate as s is 0 and negative 2. Okay, excuse me. Okay, so does everyone understand how we arrived at our s value before we continue? Okay. You guys can take your screenshot before I go to the next question. Is everyone done? So question 4.3. Is everyone able to see? Is everyone able to see now? Okay. So question 4.3, determine the equation of the tangent APB in the form y is equal to mx plus c. So we basically need to get the equation of the tangent, right? So they want us to calculate the equation of the tangent, which is this line over here, APB. Okay, so they want us to calculate the equation of the tangent APB, right? So before we calculate the equation of a line, we first need the gradient of that line, and we need any coordinate on that line. So we've got the second part, which is the coordinate. We've got coordinate P, which is on that line. And the coordinates of P are 0 and 6. So the only thing that we're missing is the gradient. So the only way I can see to calculate the gradient of this line is to use perpendicular gradients. So we are able to calculate the gradient of the radius, which is PQ. So if we were to calculate the gradient of the radius PQ, so question 4.3. So the gradient is m is equal to y2 minus y1 over x2 minus x1, which is then equal to, so let's make q our 1 and p our 2 option. So we're going to have 6 minus 2 over 0 minus 5, which would then give us 4 over negative 5. Okay, so 4 over negative 5 is our gradient of line PQ.
So
Yeah,
can we go back to 4.2?
4.2, the coordinate of S.
Yeah. You lost me the third step. 80% square root of y minus 2 minus 2.
Oh, okay, that was a mistake. It's not 16, it was plus minus 4.
No, it's the one we supposed
Okay, let's just do it on this side. So you said 4.2, right?
Yeah.
So question 4.2. Okay, let's start. Calculate the coordinates of S, right? So we had our equation of a line. As, what was it now? It was x. It was x minus 5 squared plus y minus 2 squared is equal to 41, right? Then because S has an x value of 0, we substitute 0 into here. Squared plus y minus 2 squared is equal to 41. And this becomes 25 plus y minus 2 squared is equal to 41. If we take the 25 to the other side and transpose it, we have y minus 2. Let's just do this. So we got y minus 2 squared is equal to 41, yes?
I think what you meant is that why is it next 5 don't allow it?
Yeah, I understood his question. I was just repeating everything so I can get to that point. That's why I moved this on the other side. I was going to split the screen and have two explanations. So this way, right? Okay, there's more than one way to do something, right? Like you can use a quadratic formula, or you can just factorize, or you can complete squares. Or if you've got squared, you can just square root both sides. Like for example with this, right? What I did was I square rooted, because this is also an option. Square root both sides and cancel out, and then you've got y minus 2.
16.
Oh wait, this was 16. Sorry about that. So when you square root a number, you've got plus minus, right? Okay, and 2 is equal to 2 plus minus 4, and you've got y is equal to 6 or negative 2, right? That was the one way. Now a second way was, like you said, to expand. So if you expanded, you would have had y squared minus 4y plus 4 is equal to 16, right? You would have transposed the 16 to the other side and had y squared minus 4y. When you transpose the 16, you're going to get 4 minus 16, which will then become negative 12, is equal to 0. Now to factorize this, so you should have y minus 6 and y plus 2 is equal to 0. From here you can have y is equal to 6 or negative 2. You see, either way you arrive at the same answer. You could have even completed squares after expanding. So the reason I chose to square root was just because I didn't really want to factorize and all of that stuff. I just saw a quicker option would be just to square root both sides, transpose to the other side, add it up and get an answer. You can use any method you want as long as you get to an answer, okay? Is there anyone else who has a question about 4.2 before we go on to 4.3? Okay, so I'm moving on now. Okay, so question 4.3, right? We calculated the gradient. Do we need to calculate the gradient again, or can we move on? The gradient. Okay, so the equation of the tangent, right? This question wants us to calculate the equation of the line of the tangent. So whenever you calculate the equation of a line, you need two things. You need the gradient of that line, and you need the coordinate points, any coordinate point. Or alternatively, if you have the y-intercept, you can even just use the y-intercept and the gradient. So I'll do both methods actually. Okay, so to calculate the gradient of this line, right, there aren't any points that we can use to calculate the gradient. You need to have 2 points in order to calculate the gradient, or you need to have a line that's parallel to that specific line, or you need to have maybe an angle or something that's perpendicular. And the only option that we have is the perpendicular option, because there's no line that's parallel to our tangent. We don't have the angle of alpha, so we can't use the m is equal to tan theta option. We don't have 2 points on this line to calculate our normal gradient formula, so the only other option is to use our perpendicular option. So in order to use the perpendicular option, we need to have the gradient of the line that's perpendicular to our tangent. Does everyone understand that so far?
Yes, sir.
Okay, so in the line that's perpendicular to our tangent, remember the radius of a circle is always perpendicular to the tangent of that circle. So therefore we know we need to calculate the gradient of our radius, which is line PQ. So we've got our gradient formula, which is y is equal to y1 minus y2 all over x1 minus x2. So we can make this 1, we can make this 2. So our y1 value will be 2 minus our y2 value will be 6 over our x1 value, which is 5, minus our x2 value, which is 0, and we therefore have a gradient of negative 4 over 5. So the guy that just joined, do you understand?
Yeah, I understand.
Okay, so this is our gradient of line PQ, not the gradient of the tangent. Does everyone understand that part? Okay. So now that we have the gradient, yes. Do you have a question? Okay, so let's move on. Now that we have the gradient of our tangent, now that we have the gradient of our radius, we can multiply the gradient of our radius times the gradient of our tangent, which is equal to negative 1, since they are both perpendicular to one another. So negative 4 over 5 times the gradient of our tangent is equal to -1. And we divide both sides by -4/5. So -1 divided by -4, sorry, -1 divided by -4/5 is equal to 5/4. So the gradient of our tangent is then equal to 5/4. Does everyone understand how we got the gradient of our tangent?
Yes.
Is there anyone who's confused or has a question regarding how we calculated the gradient of our tangent?
No.
Okay, so let's move on then. Okay. So now our next step. Okay, so I'm first going to use the method of substituting a coordinate point, and then second I'll use the y-intercept way. Okay. So first we need a point, right? And our point is P, 0 and 6. So we have our formula, which is y minus y1 is equal to m x minus x1. So our point is 0 and 6. So our y value is 6. So we can substitute our y value into the formula, which is y minus 6 is equal to our gradient is 5. Our gradient is 5/4 x minus 0, which is our x value. So y is then equal to 5/4 x, and when you transpose -6 to the right hand side, you get +6. So this is our equation of our tangent line, right? Equation of a tangent. Does everyone understand this way before I move on to the other way?
Yes.
So there's no one with a question. So,
No.
so the second way we can use is we've got our gradient, which is equal to 5/4, and we've got our, so we need the value of c, right? Because the equation is, sorry, the formula is y is equal to m x plus c. So we've got our value of m, we just need our value of c. And remember, c represents the y-intercept. And the y-intercept is the value of, when the graph cuts the y-axis, and our x value will be 0. And our y-intercept is actually our point P, right? So the value of our y-intercept is 6. So all you can do here is just say y is equal to 5/4 x plus your y-intercept, which is 6. This way is a bit shorter and quicker, but you can't really use this all the time because they don't always give you your y-intercept. Like you saw with the previous question, I think it was question 3, when they asked us to calculate the equation of one of the lines. We weren't given a y-intercept, so we had to use the first method. So does everyone understand both methods before we go on to question 4.4? Okay. Oh wait, did you guys take a screenshot? Right. Oh, everyone did, okay. Sure. So the next question is calculate the size of alpha, right? So in order to calculate the size of alpha, we can actually use the gradient formula, right? Because you guys remember, this is question 4.4, right? 4.4, the formula m is equal to tan theta. Okay, so since we've got the gradient of our tangent, we can actually just solve for our theta, which will be alpha in this case. So tan of alpha would then be, our gradient was 5/4. Is that correct? Anyone who wrote it down or took a screenshot?
Yes.
It was? Okay. So from here, all we do is we transpose our tan, which will be tan inverse of 5/4. And do all of you guys know how to put tan inverse on a calculator? Sure. So alpha is then equal to 51,34 degrees. Does everyone understand how we got to that answer? Okay, is there anyone who has any questions regarding that answer? Okay, sharp. So did you guys take your screenshots before I clear up? Is there anyone who hasn't taken a screenshot as yet? Okay. Okay, so the next question, calculate with reasons the size of theta. So angle theta is the one there by r, right? So they want us to calculate the length of angle theta. Let's see, how can we do that? Can we use the tan Chord Theorem? Do you guys know the tan Chord Theorem from Euclidean geometry?
Yes.
Let's see if there's any other way of doing it. Do you guys also know that cos rule? Is there anyone who doesn't know the cos rule?
No.
When you say no, like, do you not know it, or no, you know it? Okay, sharp. So we can use that, yeah? I prefer that one. Okay, so using the cos rule, right? So using the cosine rule, it's question 4.5. Okay, so to use the cosine rule, right, we need to have, so since we're using theta, we need to have what size? We need to have side PS, which is opposite theta. This is another color. So we need to have the length of PS. We also need to have the length of PQ. So Excuse me? Yeah, I'm actually thinking of something else. Trying to think. You guys know there is also another way we can actually do this. If we get, since we have the radius, right? Because we don't have r, so we can't actually use the cosine rule. I'm only thinking of that now. We can't use the cosine rule because we don't have the value of r. So we can't get PR and PS. I'm sorry, SR. So another way we can do this is, yep. Do you guys know the angles at a center theorem? I think it's the third theorem in Euclidean geometry. Yeah. Who doesn't know it? It's so cold that I can't even write straight, man. Sorry, the guy who said you don't know it. Okay, so theorem 3, right angles at a center. I'm gonna explain it now. Okay, so since we don't have point R, now we can't really use the cosine rule. But what we do have is we have the radii of the circle, right? So we can actually use the radii. We can use the cosine rule in a different way. We can use the cosine rule to actually get this angle over here, right? And remember, by angles at a center, this angle here is twice the size of this angle. So if we make this angle, let's just make it x, right? So we're going to call this angle x. So angle x is equal to twice angle theta. Okay, so we can also use this method here. No? Is everyone following so far?
Yes.
The girl that said you don't understand, what part don't you understand so I can explain? Okay. Okay. So do you see this triangle? So okay. Remember before in one of the questions we calculated the radius. So because we have the radius, right, we can calculate this triangle over here. Do you see this triangle over here? PSQ. Okay. We can calculate, using this triangle, we can calculate angle X, the angle at the center that we made, angle PQS, okay? And if we have angle PQS, because of the theorem of angles at a center, we can actually calculate angle theta, because according to the theorem angles at a center, angle theta is half the size of angle X, and angle X is double the size of angle theta. So do you understand now?
Yes, I think.
Sharp. So we need to use that cosine rule for this red triangle, right? So if we were to use the cosine rule for the red triangle, we would have, first we actually need to get a few things. So what was our radius again when we calculated it? If anyone can remember. I think it was the root of 41, right? Yeah, okay. So it was the root of 41. So this would also be the root of 41. So we've got two sides. Now we need the third side. So did we calculate S? I think we did, yeah. Question 8.2. Our y value of S, what was it? I think 6, negative 6 or negative 2 or something. Negative 2. Okay, so 0 and negative 2. Okay, so from 6, until -2 is 8 units. Does everyone understand how we get to 8?
Yes.
Because from 0 to 6 is 6 units,
Yes.
and from 0 to -2 is 2 units. So 2 plus 6 is 8 units. So this line is equal to 8, right? So we've got our 3 sides. We just need to calculate our theta. Sorry, not theta, our angle x. So using the cosine rule, we would have ps squared, which is the angle opposite our x, is equal to, then we have the two angles on the side of it, which is angle PQ. So it's angle PQ squared, and the second one is angle Angle SQ plus side SQ squared minus 2PQ times SQ, and then cos of angle x. Cos of angle x. Okay. Does everyone understand that I made that angle PQS angle x? So I'm saying cos of angle x instead of cos of angle PQS. Is there anyone who doesn't understand that? Okay, so instead of writing angle PQS, just for simplicity's sake or to have less to write, I just made that angle x. Okay, I just renamed it to x. That's all. I didn't change anything or do anything fancy. I just made that x. Do you understand? Sure. Okay. So, yep. Excuse me? I didn't hear your question. I'm trying to find the angle of x so that I can find angle theta. Because remember, once I find angle x, I'm going to use the angles at a center theorem from Euclidean geometry to find angle theta.
So I think what would be the triangle?
Yeah, I'm finding angle x using PQS. You see the triangle that I drew in red? That's the triangle that I'm using. I'm not using triangle PRS. I can't use triangle PRS because I don't have length P, I don't have length PR, and I don't have length SR, and I can't calculate those lengths because I don't have the coordinate of R. Do you understand?
Yes, sir.
Okay. Is there anyone who doesn't understand what's going on, or anyone who needs an explanation before we continue?
Can I please the question?
The question, okay. So, are you able to see the question? The question just says calculate the size of calculate the size of theta. Okay. So in order to get theta, my approach is to first calculate angle PQS, which I made angle X. Should I continue using angle X, or do you guys want me to use angle PQS? Is there anyone who doesn't understand that I made angle X angle PQS? Excuse me? I can continue. Okay, sharp. So angle PS, right? Sorry, side PS. Our PS value we said was 8, which is going to be 8 squared, which is then equal to PQ, which is the root of 41. When you square that, it's just going to be 41, right? And let's just speed up this and just make it 64 one time. So this is going to be 64, right? And then this angle, side SQ is also the root of 41. The root of 41 squared is 41 minus 2 times PQ. So PQ is root 41 and SQ is root 41. So the root of 41 times the root of 41 is just the root of 41 squared, which is just 41, right? Cos X. Does everyone understand the second step?
Yes, sir.
Okay. So next we have 64 is equal to 82 here. Wait, negative 41. Wait, what are you saying? Sorry. I just tried to like push as much as I can just for time's sake, try and do as much as we can before time ends. Do you guys want me to substitute like everything individually and do the long way? Okay. So that's going to be negative 2 times 41 is negative 82 cos X, right? Does everyone understand so far? Okay, so then we can transpose cos to the other side and get positive 82 cos X, which is then equal to 82, that was already here. I'm talking about this 82 now. Minus 64, which was transposed from the left. Then 82 cos X is equal to, that's going to be 6 plus 12 is 18. Yeah, 18. Next step is to get rid of the 82, and we've got cos of X is equal to 18 over 82, right? And in order to now get X individually, since X is an angle, all we do is we transpose cos to the other side and it becomes cos inverse, right? So we've got X is equal to cos inverse of 18 over 82, and angle X is therefore equal to cos inverse of 18 over 82, which is then equal to 77,32. 77,32 degrees. Does anyone not know how to put cos inverse on your calculator? So everyone knows. Sharp. Okay. So does everyone understand how we found angle X? So now to go on to the next step. Now we need to find angle theta because the question wants us to find angle theta, not angle X, right? Angle X was just a way to find angle theta. So to find angle theta, as you can see here, right? Angle X and angle theta, we can use angles at the center, right? The angles at the center theorem. Does everyone understand that? Okay. So angles at the center theorem, we're going to have angle X is equal to, actually we want to solve angle theta, so let's write it in a different way. So we know that angle theta is going to be half of angle x, right? And the theorem is angles at the center. Okay, so this is our reason, because the question asked us to state our reasons, right? So theta is therefore equal to half of 77,32, and theta is then equal to divided by 77.32, and theta is then equal to 38,66 degrees. Does everyone understand how we found angle theta? Is there anyone that's lost, and is there anyone that has any questions? Yes, there is an alternative way. We can also use the tan chord theorem, but personally I don't really like the tan chord theorem, so I went with this. Tan chord, okay. So tan chord theorem, né? So to get the tan chord theorem, we would have had to calculate the sum of the triangle, right? So wait, let me just clear this up before I explain it. Is everyone able to see the diagram properly? Excuse me? Oh yeah, that's what I'm doing now. So is everyone able to see the diagram clearly? Okay, so if we were to calculate the tan chord theorem, right? First thing we would have needed to do was calculate this angle here, the tan. So in order to calculate the tan chord theorem, we would have had to calculate this angle over here. Where's the color? This angle here. Okay, because this angle would be equal to this angle, right? Shit. Can everyone see that? Okay, so in order to calculate this angle on top, remember we got our value of alpha, right? Does anyone remember what the value of alpha was? I can't remember. 51.3 what? 34. Okay. So let's make this angle A, right? So angle A plus angle alpha plus, can you see this is a 90 degrees? Is there anyone that doesn't understand why this is 90 degrees? Okay. So plus the 90 degrees, you're saying? Do you not understand? Oh, okay. So angle A plus angle alpha plus 90 degrees is equal to 180 degrees. And our reasoning is sum of interior angles of angles of triangle is equal to 180, right? Does everyone understand that part? That the sum of all three interior angles of a triangle is equal to 180. So A is therefore equal to 180 minus 90 minus alpha, which was 51,34. Is that correct? 51,34. Okay. So A is therefore equal to 99 minus 51.34, and A is therefore equal to 38,66. Okay, so that means this angle over here is equal to 38,66. So therefore, using the tan chord theorem, we would just say theta is equal to tan. So why am I saying tan? Theta is equal to 38,66, and our reason would be tan chord theorem. Okay, so that's using the tan chord theorem, but personally I don't really like this theorem. Okay, so that's the second option that we could have went with. So let everyone take their screenshot of the question before we move on. I think we've got like one more question left. Okay, sharp. Is there anyone who has any questions before we move on? Okay. So the last question says calculate. The last question says calculate the area of triangle PQS. Where did the question go? So everyone see the question. Is everyone able to see the question? Okay, so calculate the area of triangle PQS. So PQS was that triangle that I highlighted in red before, right? So PQS. Okay. So in order to calculate the area of triangle PQS, we know that our area formula is equal to, so area is equal to half times height, sorry, half times base times height, right? So in this triangle, our base would then be PS, right? Which is this line over here. And we had PS as 8 units, so that'll be half times 8 times our height. So our height in this case would be from our base until our center point, right, of our circle. So from the y-axis, which is x is equal to 0, until our center point is 5 units, right? Does everyone understand how we got the 5 units? Okay. What don't you understand about how we got the 5 units? Okay. So can you see here at this point, right? Our x value is 0 because it's on the line on the y-axis. So from here until our point Q, can you see the coordinate of Q is 5? The x coordinate of Q is 5, which means at this point x is equal to 5. So from here until here is 5 units. So does everyone understand how we got 5? Okay. So it's going to be half times 8 times 5, right? So half times base times height, which is then equal to 4 times 5 is 20, right? So it's going to be 20 units squared. Does everyone understand that? Okay, there's also another way of calculating the area of this triangle, right? So the second way of doing that, can I erase, or do you guys need to take a screenshot? Okay, so the second way of doing it is to use the, have you guys dealt with the area formula where you use sine of that angle? Okay, so you're familiar with it. So to calculate the area of this triangle, we're going to be using the sine of this angle, right? Which was previously we used it as x. So we'll have area is equal to, so we're going to have the area, half of PQ times SQ sine of this angle, right? So we're going to have half. Basically, all you do is you say half of the two sides that are connecting to this angle. So for example, if your angle is like this, right, you'd have this side over here and this side over here. Or if your angle is like this and you're using this angle, you always just use the length of the sides that connect to the angle, basically. Did anyone take down what was the value of our x, this angle over here? 77 comma. Okay, thank you. So PQ times SQ times sine, let's just call it x now. So this is going to be x, which is then equal to half of our radius was the root of 41, times the root of 41 times sine of 77,36. Was it 77,36, right? Just to confirm. Okay, thank you. 77,32. So therefore our area is then equal to, so we just say half times the root of 41 times the root of 41 times sine of 77.32, and that gives us still 20 units. 20 units squared. So does everyone understand both ways of calculating the area of this triangle?